welcome to the late night stats video. Currently we are filming with my dog Clarabelle. She's very tired as it's been a long day. So I was tasked with chapter 2 of 1 of 2 for some brief review things. And I'm not only going to show you Clara, but I am mainly going to show you Clara because she's adorable. I mean, look at her. Hey, Clarabelle. Okay. Anyways, let's talk about normal distribution. A general normal distribution, as you guys know, is left slipper. Boom! The old 68, 95, 99.7. That's right there. That's the normal distribution. We've seen this before. But you might be asking me, like Claire's asking me right now, what's a right skewed distribution look like? What's a left skewed distribution look like? Oh, I'm tired too, Claire. Let me help you out. Right skewed, boom. Left skewed, boom. As you can see, skewedness is really dependent on, or at least the naming of the skewedness is dependent on the tail. For example, right skewed is going to have an elongated tail this way, and this little mound over here will be over here. Now left skewed is going to have a longer tail this way, and the mound, our little friend Mr. Mound, will be more like over here. As Claire likes to say, if you ain't talking money, I don't want to talk. As I like to say, if you haven't been talking about Z-stars yet, you've been wasting my time, and I would agree with you. Tennis ball. This is your formula for your Z-score. X minus mu over standard deviation. X being your number, mu being your mean, and that little circle with the swag being your standard deviation. Once you get that number, you can plug it into a table given to you by either AP or College Board or a textbook, and you can see, or like this one that I got online, and you can see the percentage of the distribution below that certain number. I'm sure you remember this from earlier this year and from last year, but you might want to write these numbers down if you don't remember them. 68% of the observations fall within 1 standard deviation, 95% in 2, and 99.7 in 3. Hence the rule 68, 95, 99.7. And this would be helpful for approximations used if you are asked that specific type of question on an AP test. Again, we will review the z-score formula, x minus mu over the standard deviation. Another way to get this is in the NV norm function on your TI-83 or 84 calculator, where you can plug in these values to the pretty script and it'll give you your area number. For example, like it did in this specific this picture that I was able to use for review. So your Z value is right here, calculated, and then there's that much area to the left, which is what you'll get from your Z value, and then you can do do 1 minus that, and then get your area to your right if you were asked for that. So, and it works pretty well. I apologize, it works very well. So I think that's another helpful review thing for you. That is all the time we have for today in our normal distributions review. I'd like to give you a few extra life tips, and the first one is don't blow dry your hair in the bathtub because you could electrocute yourself. And the second one is if you double knot your shoes, they're more likely to not become untied. So there you go. Spend a little extra time tying your shoes initially and you may not have to retie them. Thank you so much. Thank you, Ms. Conway. Ms. Conway, I hope you thought this video from Ethan and I was acceptable. And I just want to say you're my favorite teacher. And everyone in the class, I love all you guys. Special shout out to everyone in the class because you guys are amazing. Thank you very much. I would like to remind you that I meant to say Z-score, not Z-star in the 5th clip. Thanks again, and woof woof, as Clara says.
Hello, welcome to the first edition of AP Statistics Review with Ethan and Ford. In this one, we will be going over graphical displays, and simply graphical displays, not the analyzing of the data, just the graphical displays themselves. Now, there are many types of graphical displays, and they are exactly what they sound like, graphs that display the data. Now, I have done this before, that is why all of this stuff is written out, and it is because the microphone on my phone is broken, and you could not hear anything. So, meandering over to the types, we have a histogram, a stem plot, a box and whisker plot, and a scatter plot. Very exciting. Each of these are used in different ways, and these are the ones that are mainly used in AP statistics, but it is not limited to just these four. A histogram is this one. Ooh. You can see skews, you can see normal curves a lot better, and density. You can see many different things on this normal curve. The one right below it is a stem and leaf plot. Separated by a line in the middle, you have the 10 side on the left and the 1 side on the right, showing you what numbers are where, and you can also see how things are distributed. The next is a box and whisker plot. It looks like this. The far left extreme of the data is over here. The median is in the middle of the box, while you can also have two outside things to show this is where the majority of the stuff is, and then these guys are more outliers than anything else, and the maximum is over here. The last one that we were going over is scatter or dot plot, and that's down here. It makes dots on a graph, which can sometimes follow a trend as such. Now, moving our way over to an example problem. It was actually one that we did have on our review pack if you did the Barron's that she suggested. Now, the SAT scores, they will give you a bunch of them. I put blanks because I did not want to write out 20 SAT scores because no one cares. Now, they could ask you many different things for this. They could ask you, how is this distributed? And or, is this skewed a certain way? If so, which way? Or whatever they really want to ask, really. So, if we move on over, you can make two different types of graphs for this. I'm sure you can make other ones, but these are the easiest to see, the skew or the distribution. The stem plot looks like this. You can tell that it is skewed to the left because on the lower end of the numbers, it is highly populated with many different values, showing that there are a lot more values that ended up on this side than down here. How that would look on a normal distribution is something like this, showing that they are skewed far to the left, making the mean move to the left, but not necessarily the median, because the numbers, as you can see here, still go all the way up over here. This shows us that it is not normal, and that the numbers are skewed a certain way, which is actually the opposite of how SAT takes their test. They want them to be perfectly normally distributed. But in essence, this is how you would figure out the problem. You could answer, yes, it is skewed, and it is skewed to the left, by making either a histogram on your own and seeing which way it is skewed, or by making a stem and leaf plot and trying to visualize in your mind which way the numbers line up. I hope you enjoyed this segment. Please subscribe. It really does help. And also, get ready for our next segment from Ford Hendricks himself, as we begin to review for this incredible test we are about to take in the upcoming weeks. This is Dragon, and I'm signing off.